In this section, we're looking at surface areas of pyramids and cones. There's a few things that we need to pay attention to when we start. The most important thing is recognizing the base of a pyramid, and the base of the pyramid will be the side that's not a triangle. A triangle is usually composed of some polygonal base and then a bunch of sides that come together as triangles all meeting up at a vertex. The next thing we want to look at is the altitude. The altitude is the height of the pyramid, but it's always perpendicular to the base. So a lot of times it'll be coming to the center of the base if we're dealing with a right regular pyramid, and then going straight up to the vertex, okay, as we would in this one over here. Now, if we're looking for surface area, we don't really want the height. What we want is the slant height. We want to look at the sides of these triangles here. Notice that those are coming up the side of this pyramid, and that's why it's called a slant height, because it's actually slanted coming up. It's coming down to where it is perpendicular to the base here, which allows us to use that slant height to find the area of each one of these little triangles as 1/2. Our base here would be the side of our base times L, the slant height. So each one of these would be that. But then notice that they're repeated for every side. That's going to allow us then to use this formula. Since we're repeating all of those sides, we're going to instead use perimeter of the base in our formula, and that'll be a shortcut for finding lateral area, 1/2 for the perimeter. But the important thing is making sure we're using the slant height, remember, coming up the side, perpendicular, and not the height. We also want to make sure that we're not using one of our edges of this side over here. That's also not the slant height. But since these are triangles, we should be able to find the slant height, even if they do give us one of these other measurements. In this example, we're asked to find the amount of copper used in the roof of a birdhouse. So notice the base of this would be a hexagon where the sides are all 4. But we're not using copper for the base, we're using kind of a hollow top, where if we unfold each side of this, it'd be like we have 6 triangles that are wrapping around this base, and each one of those, since this has sides of 4, each one would have a side of 4. Well, it would be better to think about our lateral area, our formula being 1/2 PL. We think about the perimeter of our base, since we have 6 sides and each one has a length of 4, our perimeter will be 24 inches. We'll also need the slant height L, which we just need to make sure that we're coming from the vertex down to the side, we're coming to the middle of the side, and also they told us that this is the slant height, but we see that it's coming down the middle there, so that 12 is our slant height, and so our lateral area is going to be 1/2 of 24 times 12, which comes to 144, and so lateral area is 144 square inches. Next, we'll look at the surface area. For the surface area, the only thing we're doing is adding a base. And just make sure that since these are pyramids, we're only using one base on these rather than 2 like we did for prisms. Notice in this example, we have to be careful because they have not given us our slant height, which would be BA over here. Now we can start by looking at our formula. Lateral area is equal to 1/2 PL. And we might be able to find the perimeter pretty easily. We have sides of 30. And it's a square, so there's 4 sides. That'll give us 120 for our perimeter. Our slant height, though, we're going to look at this triangle. Notice that they have given us the height, and the height always comes down to the middle of a base. We're going to only be dealing with right regular pyramids because those are the ones that are really possible to solve. The other ones are more complicated and you'd have to completely take it apart. But since we're only dealing with right regular pyramids, we're going to come down to the middle of the side. If it's the middle of the side, then this part would be 15 here. We're also given the height, which is the 36.4. So we're going to use Pythagorean theorem to find this. And that's going to give us a slant height of about 39.37. I'm just keeping an extra decimal so my later answer will be accurate. And I can now plug those values in for my lateral area. 1/2, perimeter was 120, slant height was 39.37, and that will come to about 2362.17 square meters. That's our lateral area. We're asked for the surface area. So let's look at our surface area formula. We'll just take the lateral area and add one base. Okay, so my base here is a square, so it would be 30 times 30, or 30 squared, which is 900. Okay, so make sure you're showing all your work here. I want to see where all your values come from, so that when we plug into the next step, I'm going to go ahead and round this to 2 now. Our surface area is equal to 3,262.2 meters squared. Be sure to include units. Okay, next thing we'll look at are cones, and this is a little bit more complicated of a formula to remember, pi RL. The slant height is the same idea, but since it is a cone, it doesn't really matter where that slant height is taken as long as it's coming from the vertex down to a side. Now this formula, what it comes from is the fact that if you have the base, any cone is like having a larger circle with a sector cut out of it. And with that part cut out of it, it's going to be able to wrap around here. It's going to involve the circumference of this thing wrapping around. You don't really need to remember all of this, but this is where that's derived from. So we just want to remember that the area of the lateral area, like this part right here, its area is pi RL. If I want the total surface area, then I would need to also include my base in addition to that lateral area. And so we're given this formula for surface area, again lateral area plus base. It's the same as it was for the pyramid. Okay, in this example here, pi RL, let's look at our variables. R is equal to 4.7 because it's going from the center there. Our slant height, we want to make sure that we've got the right one. Yes, 13.6 is the diagonal, or is coming down the side there. So 13.6. So we have everything we need to find the lateral area. That's 200.8. We're also going to need to know the area of the base. It's just a circle, so it'll be pi r squared, which is about 69.4. And so my surface area will be 200.8 plus 69.4, which is about 270.2. Don't forget your units, and clearly mark your answer. We've got a lot here, so we want to clearly identify what our answer is.